Okay, so can anyone give me a sense here? What is testing? We say we're going to test the program. What do I mean by that? Okay, so make sure it works. Now, there's a lot packed into that statement. So, most notably, the notion of what it means for it to work. There's got to be some notion that how it should operate properly, what it should do, and your code, you're trying to demonstrate that your code correctly captures those requirements. So we often speak within computer science about the requirements for a program. A program has certain requirements that indicate how it must behave, that it must satisfy these criteria. And we're trying to demonstrate that our system correctly operates and delivers that functionality. What else are we often trying to do within testing? Besides trying to make sure that it gives the right output for the right input. What other things might we be testing?
Make sure that it handles the wrong input gracefully.
Exactly. So that's one of the most key things, and it's one of the easiest to overlook. We want to make sure that the program not only operates properly on proper input, but that it handles in an appropriate way, I'm using a deliberately vague term there, input that's not correct. For example, it could be disastrous if your program simply takes incorrect input, makes the user think that they've given correct input, gives an answer based on it, that would be very different from what they would expect if that input, had been modified to be correct. So if your program is hiding mistakes in what they're doing from them, it can be a big, big problem. There are times where we ask our systems to be able to figure out what's wrong and automatically correct it. But often we want to alert the user to the fact that something's wrong. And we need to be prepared when we write a program for it to work, not only under the convenient assumptions about properly spaced input, but for it to work in all sorts of nasty conditions. Give me an example of a nasty condition that your program will have to deal with. It's inconvenient, we don't like to have to deal with it as developers, but it's a fact of life. Okay, a null pointer exception. Why might a null pointer exception come about? So that is true. It's something we have to handle. It's often a nuisance to have to handle it. Where could that null pointer come from? Yeah, okay, so we're expecting to be able to depend on some external resource, maybe the presence of a database, maybe the presence of a network, and we can't count on it. That database isn't there. The network connection isn't working. The printer we counted on is not present. We can't get to the website we're trying to get input from. We have to be able to handle all those situations in some sense gracefully, so we don't mislead the user to thinking all is well, and when really the program has not been able to do its job. Where else might we get a null pointer from? It's a very common case. And it has to do with a resource of sorts. It's just one that's more local to the program. Okay. Okay, a file is, we're trying to read from it, and it's got write-only access, for example. That could happen, or it's not present, or it's empty. So those are all code cases. How could a null pointer result from an attempt to request memory? Yeah, no memory available. Or the amount of memory allocated to this program is insufficient for it to do its job. It's a very common case. It's inconvenient. Do we have to handle it? Yeah. If we don't handle it, what could happen? What disastrous thing could happen if we don't properly clean up after ourselves and handle that? Yeah, so we overwrite a perfectly legitimate file. the code you're going to hand in to the lab, at 11:50 p.m. on Saturday, it overwrites that with something that's empty. Maybe it corrupts the database. It's a database full of data. It's taken years to collect, and suddenly it's got garbage all throughout it. It might destroy the contents of users' files. It could wreak havoc, in short, cause user loss of value, not only being able to not do its job, it could lose value for the user, it could destroy work that they've done. So we have to, folks, we have to clean up after ourselves when we're creating these programs. We have to handle inconvenient cases. And testing helps us verify that not only that we're handling correct input properly, but that we're handling improper input, incorrect input, or input that where it didn't match our expectations. We have to be able to handle that in a robust fashion, in a resilient fashion, in a graceful fashion. I like the word. So here we're going to be talking about some elements of that general enterprise. So let me just